Welcome to the day one of a new topic, that is graphs of quadratic relations. So now we know how does a quadratic relation actually looks like. We are now familiar with the expression ax square plus bx plus c, and we have actually even factorized it now. So in today's class and in the coming classes, we are going to understand that how to actually plot it. And it is again a very useful topic. We need this understanding for coming classes as well. Even in the next coming grades, this would be of great help to you. So let's actually first begin with the very basic understanding. By the end of the discussion of this topic, you would be able to handle any question from any book related to the graph of a quadratic expression. So that's why just listen to everything very carefully. We already know that how does a linear relation looks like. I'm just taking a simple example of, let's say, y is equal to x. So we know that if I draw this y is equal to x, this linear relation, this turns out to be a simple straight line passing through the origin. So this one was a very straightforward example. Let's say if I move to a general linear relation, let's say that is y is equal to ax plus b, and if I draw it, we know that on drawing this actually turns out to be a straight line. So a linear relation, when drawn, this actually turns out to be a straight line on the graph paper in the two-dimensional space in the x-axis and y-axis. If I plot this, we know that we would be getting a straight line. We have already done this structure and this is something which we already know. So now comes this new task and this new word. So now our ultimate goal is to discuss how does this quadratic expression looks like when drawn. So this is the main task now, that how does this quadratic expression looks like. We know that the linear expression which we have seen, when drawn it turns into a straight line, which was a known figure to us, and then that we have simply drawn. So in order to understand the behavior of a quadratic expression in general, we should start with a very simple quadratic expression, that is y is equal to x square. So I'll just start with a very basic quadratic expression, that is y is equal to x square. Let's say this is the simplest example of this thing. So when drawn y is equal to x square, if I just fill the values, different values of x in order to get the different values of y, if I just plot this graph, this gives me this figure. This gives me this figure. So this figure, it is exactly a figure like this. So this figure is a new figure for us now, and that is a new name, which is a parabola. Now this is the new story. So a quadratic curve when drawn actually always results in the shape of a parabola. So this is the first very important thing that we have just heard. We know that from now onwards, we know that a linear relation when drawn results in a straight line. A quadratic curve when drawn results in a parabola. So this is the simplest example of a parabola that I have taken, that is y is equal to x square. So there are many points which we would be noticing from this parabola, and we'll take this knowledge from here onto a general parabola after this. So in this parabola, in fact in any parabola, if you can just recall a circle. So if I have to actually tell someone a circle, what will I actually clearly tell him that, okay, this is the center of the circle and this is the radius. So the two important points in the case of a circle which are to be noticed is the center of the circle and the radius of that circle. So when we draw a parabola, so the first very important point that is to be noticed is the point at which this parabola is bending. It's actually changing its direction. If we notice that from here till here, this parabola was actually going down, and from this moment onwards, this parabola is rising. So the moment actually this parabola is actually bending, that turning point is known as the vertex of the parabola. This is again a very important word for us. So this point at which this parabola is bending, this point is known as the vertex of the parabola. So if someone asks me the vertex of this parabola, I have to tell him the x coordinate as well as the y coordinate of this point. So this is the first important point that we'll always keep in our mind whenever we are discussing any parabola. Now besides this, the most important line which we have to actually keep in our mind is actually this line. Can we see that in this case, this y-axis is actually dividing this parabola in two equal halves. We can see that this part is exactly the mirror image of this part. So this line is actually the line which is dividing this parabola in two symmetrical halves, in exactly two same halves, which is two symmetrical halves. So this line which divides the parabola in two symmetrical halves is known as the axis of symmetry. This line is known as the axis of symmetry. This is the second important structure in the case of a parabola. So for this parabola, for y is equal to x square, for this particular parabola, only for this parabola, we can see that the vertex of this parabola is the origin, and for this parabola the axis of symmetry is the y-axis. Y-axis is what is the line x is equal to 0. So for this particular parabola, the axis of symmetry is the line x is equal to 0, and the vertex of this parabola is at the origin, which is 0, 0. And this would be true. So we know that if I have to teach someone a circle for the first time, so I'll just take this example of a circle whose center is at the origin and radius is whatever, let's say 4, 5, 1, whatever. But circle doesn't actually necessarily has the center as the origin only. A circle can be here as well. Let's say the center of the circle is the point 2, 3 and its radius is, let's say, 1. Even this is a circle. So circle can be having different centers and different radii correspondingly. So in the same manner, a given parabola, in this case the axis of symmetry was the y-axis and the vertex was at the origin. So what you have to learn from this example is only this shape. So this is the important part. Don't learn these coordinates. These coordinates are only for this parabola. So what is important for us is this, that a parabola looks like this. We have just discussed that this is the shape of a parabola. So this shape would be valid for in general any quadratic curve which is over here. So when we'll discuss this parabola now, because this would be a parabola, so it would be any parabola now whose shape would be exactly like this, but the vertex and the axis of symmetry would be different. Could be different, so they may be the same for certain parabolas, but the sense is important. We know that for different parabolas it could be of this kind, let's say, or parabolas would be of different categories. So one more important point that is to be noticed just now is this, that a given parabola, a quadratic parabola, would be either opening upwards like this, or they could be opening downwards like this. We can see that this parabola is opening downwards. These parabolas are opening upwards. So in this case, the parabola which is over here is actually opening upwards.